sort of backdrop, that's why I like to start with sort of the high-level IBM strategy before I drill into public cloud or Red Hat or OpenShift or Z or P or any one specific product of the IBM portfolio. Now, I'm not going to play this, but you've probably seen this American Airlines video, and I like to play this because it's a marquee account. It's well known. It's a big, complicated enterprise type of company, which is really the sweet spot of IBM. You're over 10 years old, and you've got different generations of technologies and development environments and programming environments, and that's really where IBM is the best because we have more choice. We give you lots of different choices of platforms and legacy systems and modern systems and help you to sort of merge that journey forward with what you've got and protecting that investment that you've made in the past while still modernizing it for the future. But the reason I show this video is more that it talks about the journey of modernizing, this rebooking and leveraging the cloud technologies to improve that user experience. The cloud is really just a tool. It's not the cloud. Nobody's like, I want the cloud. Who cares about the cloud? Unless it allows me to be faster, cheaper, more agile, more customer-centric. That's really what we're after. So I always like to start with that because the technologies may change, but the customer service, the improved business experience, the making products and services better, faster, cheaper, et cetera, that's really what these companies have been doing for decades. And so that's why I always start with that. Okay, so big opportunity here. And in reality, about 5x of the cloud spend is in services. So about 550 billion of this is actually in the services and in the know-how of actually moving these on-premise workloads out to this public cloud environment. Now, to date, only 20%, and everybody has seen this this slide before. But the real challenge that customers have is the security and the integration, and then the lack of skills. And so, obviously, our partners play a big part in how they can help on this skills aspect. And then obviously IBM has been investing heavily in how to address the security concerns and then the integration, how to make sort of this whole architecture of private, public, multi-cloud, on-premise, all sort of function as one abstract software-defined cloud. And that starts to play into the Red Hat story. And that ameliorates some of this multi-cloud integration challenges because you sort of abstract above these individual individual public clouds, individual multi-clouds, and you sort of ride above it at a software layer. And so this is just sort of calling out those delineations between between a mono hybrid cloud and a hybrid multi-cloud. And this being on the right, being sort of IBM Red Hat's approach. And this is what I call the software-defined cloud. So obviously our key driving forces. So I like to show this, this is how we go to how we're investing and how we're looking at the enterprise architecture. And it's really important to think about this from an enterprise perspective. It's not just the public cloud. It's not just the private cloud. It's my heterogeneous. It's my AS400s. It's my SAP on-prem. It's my HP systems, my Solaris systems, my DEC systems, my Windows systems, my Z systems. How do I get my arms around all of this IT estate, IT architecture, applications, environment, and manage it so I can adapt quickly for my business objectives, right? That's really what I'm trying to do. So these are the sort of guiding principles that have guided us in our investment and the areas we're sort of focusing our energies on. This architecture will work, obviously, for all of the IBM products. It also works for the Red Hat products that you pay for that are based on open source, but that you get enterprise support, you get security hardening, you get integration testing and all of those things. And it works, like I said, for the free open source that you don't have to pay for, but you do your own support. And it also works for third-party products like SAP. that are certified and run on this, or Microsoft tools, or BA Logic, or Oracle, or Microsoft SQL Server, or what have you. It's like the new service-oriented architecture of the past. We're saying that this is a way to architect the full enterprise for the future. And then this cognitive apps layer is really important because that's really the future. The rest of this is sort of the building blocks of the plumbing that allows me to build these next generation applications that really modernize the future experience for the customer, right? That's really what I'm after, whether it's AI or mobile or IoT or, autonomous vehicles or electric vehicles or, whatever it is. It's sort of that new experience of automation and customer centricity. And that's really what we're trying to drive, is that next experience, better experience for those customers. And so this is just sort of the mechanics or the underlying plumbing to allow that to happen. Now, across the top is the journey, because a typical company has, a typical global 2000 company has about 2,500 applications. And an application is, comprises multiple parts. So say my e-commerce, that's just one app, SAP ERP, SAP HANA. That's just a single app. There's thousands more. And so how do you sort of pick up? You're not going to pick up all 2,500 apps and just lift and shift them all. So you're going to have this evolution. And for each application, let's take a e-commerce app. Well, I've got my front end web tier. I've got my database tier. I've got my security LDAP system. I've got my FTP server. That's, I've got my catalog, my inventory management, my financial controls, all of those pieces and parts that make up just that single e-commerce app, right? So how do I pick up that whole business functioning e-commerce app and move it to the cloud? That's a real challenge. And so that's where, if I can start to tease that out into the sort of components, these microservices, then I can more easily sort of move these things around and let this sort of fabric layer, this sort of red layer here, go find those pieces and parts and string them all together and allow them to move around on different clouds, allow them to move different data centers, allow them to move across oceans, and sort of this smart red layer, which I like to think of as sort of a distributed operating system that works across clouds, works across premises, works across compute layers. And it sort of manages sort of all of those components. And so the point is, to build this out, I have to have this sort of journey and this strategy of how to go about doing that. It starts with setting up a strategy. Maybe I use something like BlueWorks Live to start doing a heat map analysis, identify all of my applications, start figuring out for each application what are the pieces and parts, what piece can move where, how do I move it, do I refactor, do I rehost, do I rebuild, all those types of decisions for every different component of that application. And then for those 2,500 applications, I got to do that journey for each one of those, right? And then nothing static. So that's just what I got today. I've also got to be building new stuff going forward. So now I've got to roll in my new development with my modernizing my existing estate, with my migrating workloads. And all of this has to sort of be organized together into my project plan, my program plans at the corporate or the worldwide sort of enterprise strategic level. So all of this is sort of moving forward at the right speed and direction. And then once I get all of this there and I'm building it, how do I manage it across all of these moving parts and pieces and components and containers and middleware and databases and cloud service providers, and and that's where this becomes a real bear and challenge. And so it's something that you want to think about. And obviously IBM's investing heavily in this space with our multi-cloud management cloud pack, of course, which is bringing together a lot of our Tivoli ITSM products from the past that we know how to do. We've been doing this on-prem, our ITSM, our ITIL processes, and what have you. We've been doing this on-premise for the last few decades. And so now we're taking that capability and modernizing those products into these cloud native services, into components, containerized components that can then be organized into these products and stacks going forward, which give you more speed and agility. Now, the big question becomes why cloud native, or why OpenShift? Why not just use virtual machines, right? EC2, Amazon, etc. You know, why don't I just use VMs? So I like this slide, and I built this, and I also click here sometimes. And the reason I do this is I go in and I show this this video from Gartner on
organizations that are moving to the cloud, and they're being surprised because they expected to save money and they may or may not be.
Right, and so the reason is this chart. And this is a study from Gartner, and she talks about companies that, you know, everybody says they're moving to the cloud because they're going to try to save money. The reality is 50% of those companies save 1% or less, right? The next 30 to 50, so these two combined is 80% of the interviewed, of the 493 companies that were interviewed, 80% of them save 9% or less, right? So the only real savers is this 10 to 15%, so that's 5%, and another 5 to 10%. So you get 10% of these 493 actually, you know, have material savings, 24 to 23% on the cloud by going to the cloud. Now, the reason I show this slide, and this is actually a good video, so I would encourage you to watch the whole thing. She's really good, from Gartner. But the reality is they try to save money, but they don't, because what they actually do is they take the same hardware they got on-prem. Let's say they have 1,000 servers on-prem, and they lift and shift straight to the public cloud as is. And these are the nomenclature for the different clouds. So D1, this is a 16-core version 3 Microsoft virtual machine. This is a Google server. And this is an IBM Compute 16 core by 16 gigs of RAM virtual machine. And this is an AWS M5 2X large. So what happens is, and if you click this link, it'll go to a study that shows that the average computer is only 6% utilized. So that means 94% of that hardware is wasted. The reason it's that way is because we engineer systems for peak. Right. So we engineer systems for peak. And that's good engineering in most engineering disciplines. If I go on a bridge, I don't want the bridge to be engineered for the average wind. I want it to be engineered for peak wind, because I don't want to be on it when a big wind comes in and it breaks. So we've done the same thing in engineering our systems. We designed these for, you know, the busiest e-commerce day, which means, you know, sometimes these systems will scale up and they'll need to grow to capacity 94%. The problem is the majority of the time, they're not running at 90% utilization. So you have all of this waste. In fact, you've got 94% waste on average, right? Okay, so that's what we're trying to address. Now, if you just lift and shift, which is what companies do, which is why 80% of the companies save less than 10%, because they just lift and shift. And I see POCs, not POCs, statement of works or quotes all the time where customers come in and say, okay, here's my Maximo export of my 1,000 servers. I want the same thing on public cloud. So we're happy to do that, but they're not necessarily going to save money. They certainly get out of the data center, but they're going to have the same amount of waste on our public cloud or on AWS's public cloud or anywhere else, unless they get smart. If they get smart and use a container orchestrator, this is what I was calling sort of that new distributed operating system, which most people are using Kubernetes today. Now you can do this also with some of the Kubernetes competitors. You can do this with Cloud Foundry. You can do this with some other technologies. But the predominant choice today is Kubernetes. And so what Kubernetes does by taking these applications from full servers and full virtual machines, if you make them just a process, then you can stack more on a given set of hardware. So you get far tighter compute density, right? And this study, if you click it, it's a Forrester study that shows customers save 80% less hardware and software using container-based technology versus virtual machines. Now, you could do virtual machines and get maybe not this quite compute dense, but you could get better than this, but it's harder to do, and people tend to not do that. And that's why this study shows 80% savings. So if we were to take this 80%, multiply it times this 1,000 servers, you'd see we only need 200 servers to do this actual computation and to actually run our workloads, right? And so now we save a lot of money. We save not only the hardware in that I have, 4 times less hardware, a lot of software costs are tied to the hardware. So my software costs go down also because I need 80% less software also. And it all hinges on being more efficient with my compute, how I leverage this hardware that I have more efficiently. Now, this is hard to do. You got to have a smart engine in here that knows how to pick these pieces up and move them. So if server 1 starts to peak, let's say app 1 starts to grow, I need to take app 2 off of this physical server and move it over to cloud server 2, right? And then let it grow. So I got to sort of do this very rapidly, because if I get rapid demand, like with the weather company I showed as an example, this has to happen in seconds. And VMs often take minutes. So that may be too slow, and I may start having downtime or customers that are waiting minutes for this server to scale up. But with Kubernetes-based architecture, since it's just a process, this spinning up and moving and all this stuff, this takes a few seconds, and sometimes it can take less than a second. So now I can respond more rapidly. And that's really sort of this magic secret sauce to getting this efficiency and getting this agility. Now, you could, one argument may be, well, okay, now we have a coronavirus hiccup, and now we get this, everybody starts to go into crisis mode at the same time. And so now we do have a problem, right? Because if all of these peaked at the same time to 100%, now in fact I may need 100 or 1,000 servers. So this doesn't work if they all peaked at the same time. So now you would have to have some ability to spin out new servers, which is one benefit of public cloud. It's far easier from an IBM perspective or an AWS perspective to say, spin up a new server for me, and Kubernetes will do that, and OpenShift will do that, and start loading my apps across new physical servers so I can grow these 200 to say 500 if a crisis comes that all of these apps are getting throttled at the same time. Now I could spin up to 500 servers and then spray out these containers across that. And then after the crisis abates, then I could spin back down that hardware to my 200 that say runs at 80% utilization. And then I don't have to pay for that 300 server delta that I needed for the crisis. So that saves money. Additionally, I can be smart, which is I can tag these workloads and say, this blue app is a development server, or this is Cognos for reporting. So in crisis mode, and that's what's saying here, right? In crisis mode, let's kick app server 3, just shut it down, or in disaster recovery mode, shut it down and allow app 1 to scale up and take its place, take that compute cycle while this Cognos app sort of goes into hibernate mode because I'm in a disaster recovery mode or things like that. And I didn't have to buy new hardware. I just use my hardware more efficiently. So all of that kind of smarts is possible with Kubernetes. And OpenShift is just an enterprise class Kubernetes with all of the additional enterprise capabilities to make it manageable and governed and secure and things like that. Okay, so that really plays into sort of this architecture of the future that I really was talking about in my earlier slide, sort of the new service-oriented architecture, which is by breaking up my apps into these sort of microservices containers, along with the IBM middleware, so my WebSphere, my DB2, my MQ series, my business process management, my RPA, my OEM, my ECM, all of these pieces and parts. If I can make them smart like this, I can have Kubernetes shuffle them around just as quickly as it does my e-commerce app. Because my e-commerce app doesn't work without the database. It doesn't work without WebSphere Liberty. And so if I can move my code with the middleware code that I depend on in this smart, fast, second, type of second tempo, in a second I can move these things around. Now all of a sudden I get really smart efficiency in my infrastructure and in my sort of applications. And that's really what I want. Now, the reality is, for a company like American Airlines or Bank of America or IBM or any company that's older than 10 years old, it's more than likely they have stuff that's not just born on the cloud. They have existing AIX systems. They have existing IBM I systems. They have mainframe systems. They have stuff that don't run in containers yet. They're monolithic. They're fast-performing C code that runs fast and is optimized for the power chip. And so those applications need that kind of performance. So the reality is I need to sort of leverage not just my cloud native stuff, but also the stuff that I have and sort of take advantage of the best of breed capability. So if I'm doing databases, then Power 8 and Power 9 actually performs better than x86 because the hardware has more threads per core. It has a faster, bigger pipe between the memory and the core, and faster pipes or buses inside of the chip between the CPU and the GPUs. So for systems that can leverage that hardware, such as artificial intelligence workloads or databases or Spark jobs or Hadoop or Watson, things like that, they're going to get more bang for their buck with that hardware. Same with Z. Z is still the best at high I/O. So if I've got jobs that have a lot of data I/O, you just can't do those kinds of volumes on x86. So I still need Z, but I still want this kind of efficiency. So that's why IBM is bringing, which we already have, we have OpenShift that runs on Z. It runs on Power. And so now I can get this same architecture I talked about over here across all of this infrastructure that I have. And so I get this sort of abstracted software-defined cloud across all of my, fit-for-purpose hardware that is tailor-made for certain types of jobs and certain types of workloads that you just can't beat. You just can't do everything on commoditized x86 architectures. And sometimes it doesn't make sense to do that. And so this is really why, which is what's exciting to me about the Red Hat acquisition, is because it really brought all of IBM together onto one strategy. All of our hardware business, our storage business, our power business, our middleware business, our public cloud business, because they all sort of fit this enterprise architecture that really is the best, in my opinion, the best architecture for the future. Like I said, from the past, service-oriented architecture of the past, this is the new sort of cloud architecture of the future, sort of the cognitive architecture going forward. And so by leveraging sort of the best of the open source that is Kubernetes, that is Docker and containers and Linux, and packaging it up into enterprise grade, secure, Red Hat supported capabilities, and then building all of the middleware that IBM has that runs a lot of these enterprise companies that IBM has invested in the past, and these companies have invested in with us and are leveraging. And now we get sort of the best of breed, and that's what's really exciting about this sort of architecture going forward. Now, as I mentioned, and as you mentioned with the cloud packs, this is really exciting because these companies have been leveraging IBM middlware. You know, when we went to the e-commerce and to the internet world 20 years ago, from on-premise closed back office applications that weren't web facing, they were client server, or they were mainframe terminal based applications or fat clients and whatnot. When we went to the public cloud, when we went to the internet, IBM obviously invested in the e-commerce and built things like WebSphere and databases that they had from the database world, the DB2s, and brought that forward and made those enterprise ready and internet ready. And so now in this next era of computing in this cognitive cloud world, IBM's taken those same applications that they've built up the past, they've modernized all of those, they've added new cloud capabilities, new cognitive capabilities. They've divested some of them that don't make sense. They've acquired many other products from internet companies like Cognos and iLog and Lombardi, and open source products like Postgres and MySQL and all of these products, and package them up into this cloud native container fashion, so you can get this speed and agility for innovation, so that I can drive that customer experience that, like I started off with the American Airlines example, that the clients are really after. And obviously it's working, right? These numbers, these metrics kind of demonstrate customers that are really seeing value from these. Some of these are, existing products and portfolio capabilities like WebSphere, but they've been modernized. But the same code that you wrote 10 years ago can run in this modern Docker-based, container-based, OpenShift, Kubernetes orchestrated platform and get these kind of efficiencies. And so it's sort of the hybrid best of breed model of the future without, ripping and replacing the investments and the great things that you got from the last 10 to 20 years with the IBM middleware. So that's what's really exciting about this sort of going forward. And you can run these on-prem, you can run these on AWS, you can run these on IBM, you can run these on Z, you can run these on P. And so that's sort of that, you sort of abstract away these lower layers of the cloud and the hardware, and it sort of becomes almost irrelevant from an application perspective, because I design above this. Now, one thing to be careful with, which is another benefit of the OpenShift, is if I code up my applications and my development life cycles into the AWS APIs. So you can think like S3 and EC2s. And if I code that into my automation scripts, if I code that into my CI/CD pipeline, so continuous integration, continuous delivery pipelines, then all of a sudden, I'm sort of tied in, I'm locked into AWS. If I want to run that same code on premise, now I've got to go unravel it and change it to run on-prem, is showing here. In other words, I can code it, but if I code the AWS APIs, then my solution only works here on AWS Outposts and AWS. But if I want to pick up my e-commerce app and decide that IBM comes out with the next generation of Quantum, and I want to use Quantum to do some traveling salesman problem that allows me to optimize my supply chain in ways that cannot be solved today without a quantum computer, right? And AWS doesn't have that. Now, all of a sudden, I've got to do a lot of engineering to pick up that app and move it to IBM, because I want to use Quantum that's over in IBM as an example. But if I coded it on OpenShift, then I can take advantage of quantum here. If Google comes out with smart new AI that nobody else has, I can leverage that. And it's the same app, right? So that's really the power of this sort of model. Or I might want to do some stuff on premise that I don't want out in the public cloud. And again, it's my same code. And so that's really the power and flexibility of this architecture, which is why I really think this is the cognitive cloud architecture for the next decade at least, and maybe the next 20 years, like service-oriented architecture has had for the on-premise for the last 2 decades. And so this is just this is a case study of Deutsche Bank using open source, and I do like to play this because it really talks about this benefit that they're really benefiting. And so I do go through that, and I would encourage you guys to play that video and talk about it with your clients. But in the essence of time, I'm going to move forward and I'll let you watch that. And this is just the immediate benefit they're getting from the products running on this architecture. This isn't even going into some of these non-functional, non-quantified capabilities that you don't even yet know, that you don't see yet. I can't quantify this future-proof benefit that I'm going to have in 5 years from now. This is just the value they get right now. 75% saving today. Not to mention the benefits that they're going to get from this. Not to mention the benefits that they get in leveraging their existing environment here. Not to mention the benefits that they're going to get in saving hardware, software, and time, agility, and innovation that they're going to get by leveraging this going forward. This is just the quantified value they got already in a short matter of time. So that's what's really exciting, because this is really the architecture for future proofing going forward. And these benefits and metrics should only increase significantly. Some may be quantified like this with quantified numbers, and some may be just agility and it's hard to measure. But that's what's really exciting about this architecture. And so I know that took an hour, but I do take an hour. I know we didn't go to the public cloud, and I'd be happy to do another video and go through the public cloud. But I really like to spend an hour talking about sort of the broad vision of IBM, because it's really a differentiator for IBM.